Extending Fitts law for tapping on surfaces angled in the depth direction. Shape-changing devices that are composed of multiple display panels and can change their angles have been reported. Their operability may differ from that of a horizontal display surface. Fitts law is a model for predicting the time for pointing tasks. This model, however, does not consider the environment comprising multiple angled display panels. This study investigated the tapping time on touch screens angled in the depth direction and expanded Fitts law. Investigation of tapping time on the 2D Fitts law task was conducted on 18 participants. The target width W and the distance A were set to 2 conditions, and the angle of the display was set to 6 conditions. In total, 24 conditions. The participants conducted 16 trials of tapping the white start circle and the red target circle, in that order, with their index fingers. A regression analysis using ID in Fitts law as an explanatory variable revealed that the tapping time predictability is insufficient for the displays angled to the back. Consequently, we hypothesized that the width of the target when looking at the display from the operator's line of sight, WIs, would affect the tapping time. By replacing W in Fitts law with WIs, IDIs were defined. The results of the regression analysis indicated that IDIs achieved an improved prediction accuracy compared with ID. An additional experiment was conducted to confirm whether IDIs applies to various multiple-angled displays. The angles of the display were set to 10 conditions, all of them were applied for both convex and concave configurations. The results of the regression analysis suggested that IDIs is not applicable to various multiple-angled displays. We considered expanding IDIs and modeling the incremental tapping time. For convex configurations, the travel distance of the finger increased as the display height increased. By replacing A with the approximated the travel distance of the finger, IDHIs were defined. For concave configurations, the smaller the space available for moving the hand, the more carefully the participants tapped the target. So, we assumed that the tapping time increases exponentially with the length of the shortest distance from the start to the target, and defined D spacelim. The results of the regression analysis suggested that the expanded model achieved an improved accuracy for both in convex and concave configurations. In this study, we extended Fitts law for surfaces angled in the depth direction by considering the operator's line of sight and hand motion. Thank you for listening.